Dear students, in this class we will take some more examples on Fourier series. We have a problem. Expand fx is equal to x sin x in the interval 0 less than x less than 2 pi as a Fourier series. We know that by the Fourier series fx is equal to x sin x is equal to a0 y2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Suppose this is the equation number 1. We have to expand x sin x by the Fourier series in the interval 0 less than x less than 2 pi. Okay, where we know that a0, an and bn are Euler's constants, and formula of a0 is 1 upon pi (0 to 2 pi fx dx). an is equal to 1 upon pi 0 to 2 pi fx cos nx dx, and bn is equal to 1 upon pi 0 to 2 pi fx sin nx dx. Now first we find out a0. a0 equal to 1 upon pi 0 to 2 pi. Here function is given fx is equal to x sin x, that is x sin x dx. Now we integrate by parts, taking x as a first function and sin x as a second function, that is 1 upon pi. First function means x, integration of second, integration of sin x is minus cos x, minus differentiation of first is 1, integration of this minus cos x is minus sin x, and limit is 0 to 2 pi. First we apply the upper limit. Upper limit is here. Now we simplify these two sign. Now these two are cancel out. Minus minus means this is plus sign. Okay. Now first we apply upper limit. X equal to 2 pi, that is 2 pi minus common cos 2 pi. Cos 2 pi is 1 plus sin 2 pi, sin 2 pi is 0, minus when we have x equal to 0, 0 into sin cos 0, that is 0, and plus sin 0 is 0, that is here we have minus 2 pi upon pi, that is minus 2. This is the value of a0. Next we find out an. Formula for an is 1 upon pi 0 to 2 pi x cos nx dx. 1 upon pi 0 to 2 pi x fx cos nx means x sin x into cos nx dx. That is, we can write it 1 upon pi 0 to 2 pi x into cos nx into sin x dx. Or we can write it a0 equal to 1 upon pi integration 0 to 2 pi, and we divide and multiply by 2, 1 upon 2 pi, and here we can write 2 cos nx into sin x dx. That is 1 upon, this is the formula for an, 1 upon 2 pi 0 to 2 pi x into 2 cos a sin b. What is the formula for 2 cos a sin b? Is sin a plus b, that is sin n plus 1 x plus minus sin n minus 1 x dx, because 2 cos a sin b is formula of 2 cos a sin b is sin a plus b minus sin a minus b. Okay, now we integrate by parts, taking this as a first function and this as a second function. Now an is equal to 1 upon 2 pi, first function means x, integration of second. What is the integration of seconds? Integration of sin n plus 1 is minus cos n plus 1 x upon n plus 1 minus minus plus cos n minus 1 x upon n minus 1 minus differentiation of first and integration of second, that is minus sin n plus 1 x upon n plus 1 whole square plus sin n minus 1 x upon n minus 1 whole square, and limit is 0 to 2 pi. Okay, now we apply this limit. First we apply upper limit. Upper limit is x equal to 2 pi. X equal to 2 pi. Here we have 2 pi into here cos 2n plus 2 pi. What is the value of cos? When we put x equal to 2, it is 2n plus 2 pi. And what is the value of cos 2n plus 2 pi? Is equal to minus 1 to the power 2n plus 2, that is minus 1 to the power even number is equal to 1. Okay. Here we have minus 1 upon n plus 1, and here we have cos 2n minus 2 pi, that is 1 upon n minus 1 minus, when we put x equal to 2 pi, then sine 2n plus 2 pi and sine 2n minus 2 pi. Sine 2n plus 2 pi is equal to 0, and similarly sine 2n minus 2 pi is also 0, and means second term will be 0. Minus lower limit, when we put x equal to 0, 0 into this whole 0, minus when we put x equal to 0, minus sine 0 plus sine 0, again this is 0. On solving, this is 1 upon 2 pi into 2 pi, and here we have minus 1 upon n plus 1 plus 1 upon n minus 1. This 2 pi is now cancelled out. N is equal to, now taking n plus 1, n minus 1 is the common LCM of this n plus 1, n minus 1. On solving this, here we have minus n plus 1, and this is plus n plus 1 minus n plus 1 plus n plus 1, that is 2 upon n square minus 1. Okay, 2 upon n square minus 1, and here it is clear that this is here, what is n? Here n is from 1 to infinity. N equal to, here n is a positive integer, 1, 2, 3 up to infinity, but this value is not defined when n equal to 1. Okay, for n equal to 1, we have to separately find out the value of an. So what is the formula for n equal to 1? When n equal to 1, then a1 equal to, we simply put n equal to 1 here. Okay, formula is 0 to 2 pi, 1 upon pi, 0 to 2 pi x sin x, and cos nx means cos x dx, that is 1 upon 2 pi 0 to 2 pi x divided by 2 and multiply by 2, 2 sin x cos x, that is sin 2x dx. Okay, now integrating by parts, taking x as a first function and sin 2x as a second function. That means 1 upon 2 pi. First function means x. Integration of second means minus cos 2x upon 2. Integration of second minus differentiation of first and integration of this term, that is minus sin 2x upon 2 square, and limit is 0 to 2 pi, that is 1 upon 2 pi. First now these two, this we simplify these two sign, minus minus plus. Okay, first we apply x, upper limit x equal to 2 pi, that is 2 pi, and here cos 2 pi, cos 2 pi is minus 1, cos 2 pi is minus 1, cos pi is minus 1 to the power n, and cos 2 pi is minus 1 to the power 2n. that is minus 1 to the power even number, that is plus 1. So we have this minus sign upon 2 when x equal to 2 pi, it is cos 4 pi. Cos 4 pi is plus 1 plus sin 4 pi is 0. When x equal to 0, 0 into this 0 and plus sin 0 is 0. Now this 2 pi's cancel out. What we have? A1 equal to minus 1 by 2. Okay? Means here this series is not defined when n equal to 1. For n equal to 1, we have to find out all terms, means next we find out bn, and also for n equal to 1, that is b1. Now what is the formula for bn? Formula for bn is 1 upon pi 0 to 2 pi fx. Fx means sin x and sin nx dx. This is the formula for bn. Okay, this is the formula for bn. Now we apply this formula. Now we can write it. This is equal to 1 upon pi. We divide and multiply by 2. Here 0 to 2 pi x two sin nx into sin x dx. Here we can apply the formula 2 sin A sin B, that is bn is equal to 1 upon 2 pi 0 to 2 pi x into, what is the formula of 2 sin A sin B? Formula of 2 sin A sin B is cos A minus B minus cos A plus bx dx. Okay, now we integrate by parts, taking this as a first function x and this as a second function, that is bn is equal to 1 upon 2 pi. First function means integration of first function as it is. Integration of second, what is the integration of second? It is integration of cos n minus 1 x is sin n minus 1 x upon n minus 1 minus sin n plus 1 x upon n plus 1 minus differentiation of first, differentiation of x is 1, and integration of sin n minus 1, that is integration of this cos minus sin, integration of sin x is minus cos x, and integration of sin n minus 1 is minus cos n minus 1 x upon n minus 1, that is cos n minus 1 x upon n minus 1 whole square. Again integration of this minus minus plus cos n plus 1 x upon n plus 1 whole square, and we apply the limit 0 to 2 pi. One upon 2 pi. First we apply upper limit. Upper limit is x equal to 2 pi. Here when we put upper limit x equal to 2 pi, here 2 pi sine 2n minus 2 pi minus upon n minus 1 and sine 2n plus 2 pi, and we know that sine 2n minus 2, sine 2n minus 2, sine 2n plus 2, sine 2n minus 2 all are equal to 0. Means first term is 0 when we put x equal to 0, 2 pi, it is 0, minus when x equal to 2 pi, it is minus cos 2n minus 2 pi, and cos 2n minus 2 means minus 1 to the power 2n minus 2, and 2n minus 2 is an even number, minus 1 to the power even number means plus 1. What do we have here? Here we have minus, this minus is common, minus 1 upon n minus 1 whole square and plus cos 2n plus 2 pi, again this is cos 2n plus 2 pi, this is plus 1, 1 upon n plus 1 whole square minus lower limit is x equal to 0, lower limit is x equal to 0, 0 into everything 0 minus cos 0 is 1, that is minus 1 upon n minus 1 whole square plus cos 0 is 1, 1 upon n plus 1 whole square. Okay, now we solve what we have. Finally what we have here, bn is equal to 1 upon 2 pi, here we have 1 upon n minus 1 whole square minus 1 upon n plus 1 whole square, and here this minus is common, means here we have minus 1 upon n minus 1 whole square and this minus and minus plus 1 upon n plus 1 whole square. Now these two are cancelled out and these two are cancelled out, then Vn equal to 1 upon 2 pi into 0, that is 0. But we know that this series is not defined when n equal to 1. Okay, it is here n equal to 1, this series is not defined, and also we are having an n minus 1 terms. So we have to find out value of Bn when n equal to 1. N equal to 1, Bn will be B1, that is 1 upon 2 pi 0 to 2 pi x sin x into sin nx, sin nx from here, sin, when we put n equal to 1, it is sin x into sin x dx means this is 1 upon 2 pi 0 to 2 pi x into sin x sin square x. Okay, this is sin square x, we can write it here 1 minus cos 2x upon 2, and it is 1 minus cos 2x upon 2 we write here, and this is dx. Now integrate by parts, taking this x as a second function and 1 minus cos 2x as this x as the first function and 1 minus cos 2x as the second function. 1 upon 2 pi. First function means x. Integration of second, 1 minus cos 2x, integration of this x minus sine 2x upon 2 minus differentiation of first 1, integration of this term. Integration of this term is x square by 2 and integration of sine 2x is plus minus means minus minus plus cos 2x upon 2 square and limit nx, and this is 0 to 2 pi. Means b1 equal to 1 upon 2 pi. Now we apply limits. When x equal to 2 pi, here 2 pi and here we have 2 pi minus sine 4 pi. Sine 4 pi is 0. Minus when x equal to 2 pi, here we have 2 pi means 4 pi square upon 2 plus cos 4 pi is 1 upon 2 square minus when x equal to 0, when x equal to 0 the first term will be 0 minus here we have when x equal to 0 this term is 0 plus cos 0 is 1, that is 1 upon 2 square. b1 equal to 1 upon 2 pi. Here we have 4 pi square minus here we have 2 pi square. Here we have minus 1 upon 4 and here minus and this minus plus 1 upon 4. Now these two are cancelled out and bn is equal to 1 upon 2 pi into 2 pi square, and this is equal to not bn, this is b1, that is b1 is equal to pi. What we have? b1 equal to pi. Now what we have calculated here? Here we have calculated 3 terms. Number 1, we have calculated here a0. Here a0 is equal to minus 2, and we calculated an is equal to 2 upon n square minus 1. Then we calculate a1, we get here minus 1 by 2. After that we calculate bn. bn is equal to 0. Here we have bn is equal to 0 and b1 equal to pi, and bn is equal to 0 and b1 is equal to, what is the value of b1? We have b1 is equal to pi. Okay. Now by the Fourier series we know that from equation 1 x sin x is equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity Bn sin nx. Okay, and we know that this series is we have calculated separately value of a1 and b1. Now we can write this as a x sin x is equal to a0 by 2 plus a1 cos x plus n equal to 2 to infinity an cos nx plus b1 sin x plus n equal to 2 to infinity bn sin nx, that is x sin x a0 by 2, that is 1 upon 2 into minus 2 plus a1 means minus 1 by 2 cos x plus summation n equal to 2 to infinity an means 2 upon n square minus 1 cos nx plus b1 sin x, b1 means pi sin x plus summation n equal to 2 to infinity bn is 0 sin nx. Okay, on simplifying this, these two cancel out. Here we have minus 1 and what we have here plus this pi sin x minus 1 by 2 cos x plus, now this we can open this series, plus 2 upon 2 square minus 1 cos 2x plus 3 upon 3 square minus 1 cos 3x and so on. And this is the expansion of this function x sin x with the help of Fourier series. And this is the final answer. I hope this is clear to all of you, and thank you very much. Have a nice day. Bharat Mata ki Jai.